Hello, my dear students. I'm back with my software engineering lectures prescribed for computer science and engineering for third semester of BE degree. If you like to, if you like my videos, like it, subscribe it, and share it among your friends. We will start with the first module, that is Introduction to Software Engineering. Here, the contents goes like software crisis which we are facing in today's world, need for the software engineering, professional software development, software engineering ethics, and we're going to study some case studies along with your software processes and software models. Objectives of this module is to understand the importance of software engineering, to understand the development of different types of software systems with different software engineering techniques. Software failures are due to two important reasons, as we know. That is, one is the increasing demands where existing software engineering methods cannot cope up and new software engineering techniques have to be developed to meet new demands. And the other is low expectations, as many companies doesn't relatively believe to follow the software engineering techniques and have drifted into software development as their products and services have evolved. So the crisis manifested into several ways, such as projects which are running over budget, which are running over time, that is, which will take more deadline to cover up, the software which was inefficient to so to in the development and to satisfy the customers, and the software which is low quality, software which did not meet the requirements of the users are have been failed due to so many reasons, projects which are unmanageable and code difficult to maintain later on, and software which was never delivered. Software engineering is intended to support professional software development rather than individual programming. It includes techniques that support program specification, design, and evolution. A professionally developed software system is often more than a single program. The system consists of a number of separate program and configuration files that are used to set up these programs. It may include software documentation, which describes the structure of the system, user documentation, which explains how to use the system, and websites for users to download recent product information. So here are some factors which contribute to the need of software engineering, as we want large softwares which becomes large from the perspective of engineering and step to give scientific processes, scalability, the cost, dynamic nature, and quality. So here, with respect to this software, as an example, software for PCs, databases, word processors, which we use in daily basis, are considered as generic products, and customized, which are also called as bespoke products, which are commissioned by a particular customer, such as you take example of your banking systems, your electronic devices, and system written to support a particular business process, etc., comes under your customized products. So there are two fundamental types of your software products. Software engineers are more concerned with developing software products, which can come into two categories, such as generic products and customized products. You can say generic products are standalone systems which produced by a development organization and sold on in the open market, which you can just which everybody can use for their purposes. Software engineering is an engineering discipline which concerns with all aspects of software production, from the early stages of system specification through to maintain the system after it has gone into use. So some of the very important questions are FNQs, you can say, are: what is the software? What are the attributes of a good software? what is software engineering and how it is different from your system engineering, what are the fundamental software engineering activities, and the differences between software engineering and computer science. The difference between the software engineering and system engineering also, the key challenges are the crisis faced by the software engineers throughout the world, the cost of the software engineering, the best software engineering techniques and methods, and the differences which the web made by software engineering and by which led to the availability of the software services and possibility of the developing highly described service based systems. Some of the questions I have lined up here with answers. You can just go through this slide. Like other engineering disciplines, software engineering is also carried out within a social and legal framework, so which limits the freedom of people working in that area. So it is very essential to have certain attributes of a good software, which says maintainability, dependability and security, efficiency and acceptability are very, very important attributes of any good software. So where maintainability can be can be defined as it's a critical attribute where because software change is an inevitable requirement of a changing business environment and we need to maintain it. Software dependability includes a range of characteristics which includes also the reliability, security, safety, and it should not cause any physical or economic damage in the event of system failure. Efficiency comes with software which should not make any wasteful use of system resources such as memory, processor cycles. Therefore, efficiency is very, very important, which also comes with responsibility of processing time, memory utilization, etc. Software must be acceptable to the types of users for which it is designed. That is, it must be understandable, usable, compatible with other systems which are getting used. So these are very important attributes of your good software. So as the four fundamental activities lies with software engineering as engineering discipline, we have some of the processes are the steps in the process such as software specification, software development, software validation and software evaluation. As an engineering, as a software engineer, one must accept his or her job, which involves wider responsibilities than simply the application of technical skills. One must also behave in an ethical and morally responsible way if it has to be respected as a or he has to be respected as a professional engineer. Some of the notion of professional responsibilities are confidentiality, competence, intellectual property rights, and computer misuse, where it says we should have respect the confidentiality of employers or clients irrespective of whether they are from whether or not a formal confidentiality agreement has been made by the company or not. We should not misrepresent your level of competence. That is, you should not knowingly accept work which is outside your competence, which you cannot do or which cannot deliver on time. And one should be and aware of the local laws governing the use of intellectual properties such as patents, copyrights, and one should be very careful to ensure that it should not be violated. And computer misuse, which says that you should not use your technical skills to misuse other people's computers or their privacy. We'll come up with next topic in my next video. Till then, just stay tuned and just go on with my videos. Thank you.